All right, guys, so we're going to do a quick review here on simplifying radicals. And so the first thing you want to know is what are the perfect square radicals? For some of you guys, this is going to make it a lot easier. And so the perfect square radicals are shown on the left-hand side of the screen here. The square root of 4 is, and I'm trying to get mine going here. Okay, so I have no click here. All right, this is working out fantastic already. There we go. There's the first one. Square root of 4 is 2. The next one, square root of 9 is 3. The square root of 16 is 4. The square root of 25 is 5. Square root of 36 is 6. Square root of 49 is 7. And 64 is 8. And the square root of 81 is 9. And you're going to want to know those. I'm going to show you two ways to simplify radicals today. And I'm hoping that the first one makes more sense because it's actually the faster and easier way to go. But I will give you guys a way to do the other one as well. Okay, so here we go. We're going to go on. First of all, we're going to talk about multiplying radicals. Radicals can be multiplied no matter what number is inside or outside. So when you multiply radicals, you multiply the numbers outside together, and then you multiply the numbers inside together. So my first example here, root 3 times root 2. You can multiply the 3 and the 2, you get root 6. 2 root 5 times 4 root 6. You can multiply the 2 and the 4 and the 5 and the 6 together. So whatever's on the outside gets multiplied together, whatever's on the inside gets multiplied together. Same thing here. Take a look. There's 4 root 11, but there's nothing on the outside here. So you got to envision the 1 that's right here. So when I multiply that, it's 4 times 1 and 11 times 2. Same thing with the root of a times b. If they're both inside, I can multiply them and they both stay inside. The first way to multiply radicals is by using perfect square radicals to simplify non-perfect square radicals. Radicals can be split apart using multiplication. So just like we were multiplying on the previous slide, we can now split them apart into multiplication. So the idea in simplifying radicals is to split the radical into one perfect square radical and another non-perfect square radical. So that's why I went through those perfect squares at the beginning. So take a look at my first ones. So I've got the square root of 24. So all those perfect square radicals that we talked about, root 4, root 9, root, what was the next one? Root 9, after root 9 comes root 16, then root 25. So I want to think about which one of those perfect square numbers goes into 24. Well, I know that 4 does. So I can split this up into root 4 times root 6. Notice the idea here in simplifying radicals is to split the radical into one perfect square radical. There's my perfect square radical right there, the root 4. And another non-perfect square radical. There's my non-perfect square radical right there. But I know that the square root of 4 is 2, so I can put that down. I can't square root 6 anymore, so it's going to stay the square root of 6, and that is the easiest way to simplify the root of 24. Let's take a look at another one. Square root of 50. Think about all those perfect squares that I just went through. Again, they were 4, 9, 16, 25, 36, and so on. Which one of those numbers goes into 50? Well, 25 does, and that is your perfect square radical. 25 times 2 is 50. Now, you could have also said 10 times 5 is 50, but 10 and 5, neither one of those are perfect squares. So if I'm going to break this up, I want to try and break it up into a perfect square. The square root of 25 is 5. Square root of 2 is still the square root of 2, so it stays. Square root of 45. Again, I go through my list. Start small if you're not sure. Does 4 go into 45? No. You go to the next one. Does 9 go into 45? Yes, it does. Okay. There's my perfect square right there. Square root of 9 times square root of 5. 9's my perfect square. It's going to be 3. 5 does not simplify. There's your final answer right there. Last one for this method. Square root of 96. This one's a little bit tougher here. So you got to be fairly good with multiplication, or you get out a calculator. You say, does 4 go into 96? Actually, it does. But is there anything bigger? Does 9 go into 36? No. Does 16 go into 36? Yes, it does. So this is actually root 16 times root 6. The 16 will simplify to 4, and the root 6 goes back in. Okay? Now, the second way to do this, well, actually, before we get there, I guess, if the radical has a number on the outside, simplify the radical as usual, then multiply by the number on the outside. So check it out. 2 root 18. All right? Forget about the 2. Let's just talk about the 18 here. 18 is root 9 times root 2. There's your perfect square. Square root of 9 is 3. The root 2 comes back into play, but then that 2 that was up here on the outside, that needs to come back down and get multiplied by the 3 on the outside now. Remember, numbers on the outside get multiplied by the outside, numbers on the inside get multiplied by the inside. And I get 6 root 2. 5 root 12. Forget the 5 for a minute. Let's simplify root 12. Root 12 is root 4 times root 3. The square root of 4 is 2. Square root of 3 goes back in. Bring your 5 down from the front. Multiply it by the 2, and you get 10 root 3. Piece of cake, right? Looks like I got one more. Root 27. 9 times 3. There's your perfect square. Split the 9, or square root the 9, excuse me. That's going to be 3. Bring down your root 3, and bring down the 3 from the front and multiply it by the new 3 in the front, and you get 9 root 3. All right, second way to do these is to use what I call a factor branch. I'm sure all you guys are familiar with factor trees, but I do a factor branch, and it's a little bit more organized. So check it out. First thing I'm going to do, I want to simplify the square root of 24. So I'm going to draw a line right here. I'm going to put 24 on the left. I'm going to put a division sign up over the top. And then I'm going to start with very small numbers, prime numbers to be exact. I'm going to start with the smallest prime number, which is 2. Can I divide 24 by 2? Yes, I can. What is that result? It's 12. So I bring the 12 back down over here. And then I ask myself the same question. Can I divide 12 by 2? Yes, I can. So I do that division. 12 divided by 2 is 6. I bring that down here. Can I divide 6 by 2? Yes, I can. So I do that division. I bring the result down here. Can I divide 3 by 2? No, that doesn't work. So I move up. Can I divide 3 by 3? Yes, I can. 3 divided by 3 is 1. When I get to 1 over here, these are now all the prime factors of 24. Think about it. 2 times 2 is 4, times 2 is 8, times 3 is 24. So what you got to envision is that all of these numbers are still inside my radical because they all multiply to 24. But I'm going to take these first two and I'm going to multiply them together. 2 times 2 is 4. Remember, everything over here right now is still inside the radical. So this actually makes a root of 4. These two guys here make a root of 4, which is 2. So these guys basically get to leave the root. The 2 and the 3, however, make a root of 6, and I can't simplify that. So now I can multiply these two guys together, and I get 2 square root 6. Let's try another one. The root of 50. I'm going to draw my vertical line. I'm going to put 50 on the left, put a division sign on the top. I'm going to start with 2, and then I'm just going to work my way up. Does 50 divide by 2? Yes, it does. 50 divided by 2 is 25. Does 25 divide by 2? No. So I move up. Does 25 divide by 3? No. So I move up. Does 25 divide by 5? Wait, Mr. Cornelius, you forgot 4. No, I didn't. 4 is not a prime number. I only want prime numbers over here. So I tried 2, it didn't work. I tried 3, it didn't work. I go to 5. 25 does divide by 5. That's going to be 5. Does 5 divide by 5? Yes. 5 divided by 5 is 1. Okay, that's how I know I'm done. Think about it. 2 times 5 is 10, and 10 times 5 is 50. So all 3 of these numbers are underneath the root. Now, since they're all under the root, I'm going to take the 2 and I'm going to leave it under the root. Why am I doing that? Because I can't square root of 2 all by itself. But the 5 times 5 is really the root of 25, which is equal to 5. My final answer here, 5 square root 2. So just like you would do with factor trees, but way more organized than factor trees. Let's do a couple more here. Square root of 45. Draw your line, put your 45 on the left, your division sign on top. Does 2 go into 45? No. Does 3 go into 45? Yes. So I put a 3 there. 45 divided by 3 is 15. I continue with 3. Does 3 go into 15? Yes. So I divide 15 by 3, I get 5. Does 3 go into 5? Obviously not. Does 5 go into 5? Yes. The answer for that division is 1. Anytime I get a pair of numbers that are the same, it's going to create a perfect square root. And I can square root that 9, and it's 3. Anything that doesn't have a partner to pair up with that is exactly the same has to go back in the root, and I end up with 3 square root 5. Okay, so for our last one here, we're going to do the square root of 96. So we're going to set it up the same way we did before with our 96 and our division sign and our vertical line. But this time, again, we're going to start out small. We're going to do 2. 96 divided by 2 is 48. 48 divided by 2 is 24. 24 divided by 2, you'll notice I'm still going with 2's over here. That's 12. I'm going to continue with 2 until I can't do it anymore. 12 divided by 2 is 6. 6 divided by 2 is 3. Obviously, I can't divide that by 2, so I move up to 3 again. 3 divided by 3 is 1. Now, this time we've got a lot more numbers over here, but remember, for each pair, you've got to remember that that pair, and that went a little too quick, but I'm going to go through this. 2 times 2 is the square root of 4, and the square root of 4 is 2. This pair of 2's right here also makes another square root of 4. That's 2. This 2 and this 3 do not pair up. They go back in the root as 6. And now I multiply 2 times 2, which is 4, and then the root 6. And there you go.